Welcome again, Wildcats. Today we're looking at Thursday, January 4th, domain and range on page 40. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. So reasonable domain and range on page 40. Domain is the set of values of the independent variable for which a function or relation is defined. A way to remember domain is Dixie. Okay, so domain is input, x-axis, independent. You would update your domain part of the notes. All right, now let's look at range. Range, the set of values of the dependent variable for which a function or relation is defined. Range, or another way to understand range is ROY. So range, output, y-axis, dependent. So a way to remember domain and range is Dixie-Royd. So domain, input, x-axis, independent, range, output, y-axis, dependent. All right, so if you would finish up your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example 1. Beyonce's lemonade stand can sell at most 50 cups of lemonade in a day. Her daily profit is modeled by P of C equals 0.75C minus 8.75, where profit P is a function of cup C. All right, now the easiest way to remember independent dependent is independent is the variable inside of the equation, okay? And the dependent is always what's outside, okay? So in this case, the inside variable is C, so the independent is C. The number of cups of lemonade. Okay? So the dependent is the P of C, which equals amount of profit. All right. It says describe the domain for the context of the problem. Okay? It says here that you have at most 50 cups. So when it comes to cups, your domain is between 0 cups, because that's the least you can have. Okay, can't have negative cups. So 0 cups, which is less than or equal to C equals, which is the number of cups, less than or equal to 50. And basically what that says is the number of cups is between 0 and 50, including 0 and 50. Okay. Now you also have to state, though, that C is an element of the whole numbers, meaning cups can be 0, 1, 2, 3, 4, 5, 6, but no decimals or fractions. Okay. All right. Now describe the range. Well, using the function, okay, if you have 0 cups, you plug in 0, you're left with negative 8.75. So your range is between negative 8.75 less than or equal to P, which is profit, less than or equal to, and then you plug in 50 for C. So 0.75 times 50 minus 8.75 will be 28.75. Where P is an element of all real numbers because you can have decimals. Okay. All right, let's look at example 2. The area of a circle is found by A equals pi r squared. Your teacher asks you to construct a circle that has a radius of at least 2 inches. Okay, so again, the independent variable is the inside variable, which in this case is r. That's how easy the independent is. Look for the inside variable. So r is the radius of the circle. Okay. Now the the dependent would be the A, which is the area of the circle. Okay. Describe the domain and context of the problem. Now it says at least, the radius is at least 2. That means the radius can be greater than or equal to 2. Where R is an element of the all real numbers, greater than or equal to 2, because you can have decimals and fractions. All right, now the range, if the domain is greater than or equal to 2, you plug in 2, so the area equals pi times 2 squared, which equals 12.56. So that means the area is greater than or equal to 12.56, where area is an element of all real numbers. And all that's saying is that you can have decimals or fractions for the area as long as they're greater than or equal to 12.56. All right, let's take a look at the next example. Example 3, Mr. Luke has a lot of pencils, 2,228 pencils to be exact. He sells them for 25 cents each. This situation is modeled by y equals 0.25x, where y is the amount of money he takes in and x is the number of pencils. Again, the independent variable is always the inside variable, in this case x. So x is equal to the number of pencils. Okay, then the dependent is the remaining variable, so y, and y is the amount of money. All right, describe the domain and context of the problem. So basically, Mr. Luke has the most 2,028 pencils. The least he can have is 0. So your domain is 0 less than or equal to x, where x is the number of pencils, less than or equal to 2,228. But you have to state that x is an element of the whole numbers, meaning it's between 0 and 2,028, but it can only be whole numbers. So 1, 2, 3, 4, 5, 6, 7, 8, so on. Okay? All right, now the range at $0, 0.25 times 0 is 0. Okay? So the range is 0 less than or equal to y, the money, less than or equal to y equals 0.25 times 2,228, which equals 557. So if Mr. Luke sells if he sells no pencils, $0. If he sells them all, he'll make $557. And y is an element of the all real numbers. All right, let's take a look at last example, example 4. Okay. F of x equals negative 2x squared plus 5x plus 3 is graphed to the right. Highlight the part of the function that would represent the distance, and I'm going to change that. The height should actually be the height in yards traveled by a wildcat football over time x in seconds when kicked. All right, so it says highlight the part of the function that represents the height. So the height would represent here and here. So the height's between here and here. Okay, and it's only in the first quadrant because you can't have negative time or yards. So the independent, again, always the inside variable, which in this case is x. So x is the number of seconds. And then the dependent's the remaining variable, which in this case is f of x. which is height in yards. All right, describe the domain. So the domain, again, is from left to right, or you can look at it using the function, but I think just looking at the graph, you can look at it here. So the ball is in the air from between 0, this is hard to see, but I'm going to give you the number. The tick marks are hard to see, but that's actually at 3. So the ball is in the air between 0 and 3 seconds. So your domain is 0 less than or equal to x, where x is number of seconds, less than or equal to 3, where x is the element of all real numbers. Now your height, it hit the ground at 0, and the highest is hard to see, but it's 6. So the height was between 0 and 6 yards. And where y is an element of all real numbers. All right, so that pretty much concludes the examples. If you had some trouble with any of them, remember I will go over any and all the examples in class on Thursday, January 4th. That you have two options. You can wait for me to go over some examples in class, or if you understood them, you can move on and start working on the assignment. Either way, have a wonderful Wildcat